ratio, and one other test.
Okay. And the ratio test is probably the most important one, because the ratio test is what is used to determine the interval of convergence. Just remember that. When they start asking you about what's the interval of convergence, you usually start with taking the ratio test.
Okay.
Okay? But let me bring up some SAT stuff here. Now, let's see. Shall we go straight to high degree of difficulty? In fact, this might be a combination of medium and high. No, it doesn't look like it. Looks like it's just high. Let's look at some of these and see what we got. Now, all of these aren't necessarily high degree. I took the picture of the whole page, so some of them might not be high degree of difficulty, but they'd probably be medium at least. So this is a good place to start.
Okay. So are we doing number 18?
Yeah.
Wouldn't it just be 6 pi plus 6?
Diameter is 6. Well, so 6 pi would be the original.
Mm-hmm.
How much more do we have? I mean, 6 pi would be the circumference of the circle, but once you cut it in half, how much more? You add 12, yeah. So it would be C. So what's the first thing we need to do here?
We need to find the total area.
And then the area of the shaded region, and the answer will be what? The ratio of those.
Yeah.
In other words, it'll be probability they're looking for will be the area of the shaded region divided by the area of the big circle.
Right.
Now, they haven't given us any measurements. They haven't given us diameters or radiuses or anything. But since they're asking about a ratio, that's probably going to cancel out. So we can use the variable. And undoubtedly, it's going to disappear by the time we get done. So, first of all, what's the area of the shaded region? And let's define a few things here. We will let that be D. The diameter of the small circle will be D. So the area of the shaded region is what? That's the area of the middle circle minus the area of the inside circle.
Yeah.
Okay. The area of the middle circle, what's its radius?
2D.
So
3D?
well, let's look at it. A to B is equal to the diameter, right?
Yes.
So A to B is D, but from the center of that circle to A is half D.
Oh, so it's
So the
1/2.
radius of that middle circle should be 3/2 D
Gotcha.
squared pi minus the area of the middle circle, which is pi times 1/2 D squared, right?
Right.
And the area of the big circle is D plus half D, so 5/2 D squared times pi, and I left a D off here. Okay. So now we can see that all of our D squareds are going to go away. Our pi's are going to go away. Our D squareds are going to go away. And we have 3/2 minus 1/2 in the numerator and 5/2 in the denominator.
So you can copy dot flop that?
Yeah, I can, the numerator becomes 1. The denominator flipped, multiplied, becomes 2/5. That's not an answer. Ah, I see why. These numbers, 3/2, were squared. In other words, I couldn't just cancel the D squared. That squared applies to the 3/2, it applies to the 1/2, and it applies to the 5/2. So these numbers are not what I said they were. It's going to be 9/4 minus 1/4 all over 25/4. That's 8/4 over 25/4, 8/25.
That is an answer.
And that is an answer, yeah. Doesn't mean it's the right answer, but I definitely see where I made the mistake the first time. You know, I canceled out the D and the squared, and yet the squared applied to the 3/2 and the 1/2 and the 5/2. So, all right. It's a fairly high degree of difficulty one, for sure. You get the slope of that line.
You have to find out what K is.
Well, that's what they're asking.
The slope would be 2 minus K over 3 minus 0.
Okay. Solve that.
Multiply the right side, the left side by 2. No, you'd want to get rid of the 3. Never mind. So
Let's cross multiply. We could multiply both sides by 6. Might be the best way to go. Or let's just cross multiply. 4 minus 2K equals minus 3. That's going to be the easiest way. Now move the 3 over to there, the K over to there, and we get K equals 7/2. Answer C. Now, there's another way to do this that might be a lot faster. First of all, we can eliminate A, right? In other words, we can tell that K is positive.
Yeah, it's just going to be -6.
Right, and we can eliminate 1/2.
We can eliminate D and A. Well, D and E too.
Well, I'm not sure. How do we eliminate those? In other words, is all we can tell is that K is above 2 and positive. So we could back solve it starting with these three. In other words, you could do the two easy ones. 5 would definitely not work. 8 does not work. By process of elimination, we don't even have to do the math to decide that that works. So it's really a question of whether you want to do it algebraically or back solving. But one thing that's worth noting here is that back solving, frequently happens with back solving, is that you can throw out half of the ones that you would have to try. And it's real easy to try the others. In other words, you try 8, certainly 8 minus 2 over 0 minus 3 does not equal a half, nor does 5. As soon as you throw out D and E, you're only left with C, and you don't actually have to do the math to check it.
Gotcha.
All right, 474 here. Oh, I got these out of order. Oh, that's because I'm doing hard ones only. I don't have, they're not every page. Hold on. Well, gosh, this looks pretty familiar. So let's do it again.
So -3 minus Z over 5 minus -7.
Okay, so that becomes 12. Notice now we have equal denominators, so I can just set the numerators equal. D. Now this one actually would be a little bit harder to back solve. I'm not sure that we can eliminate any of these numbers, not in the same way that we were able to on the last one. In other words, on the last one we could look at the graph and know we could eliminate some of those. But it's technically possible that that would be 1/4, I guess, or 1/2, or 1 or 2. So I think this one we have to solve algebraically pretty much. I mean, we could still back solve. We could still try all of these. Problem is that's going to be pretty laborious, especially doing the fractional ones. What is going to be the best way to solve this?
Oh boy. N is the number of turtles in the pond. So
the key information is we know that there are 160 turtles 9 years after. And the turtles have doubled every 3 years since the pond was discovered. How about back solving? Agreed? Do you see why back solving should work very nicely here?
So just set n is 160 and try different values of...
No, this is a case where we are automatically going to know whether our answer is too small or too big, right? When we try it.
Right.
In that situation, you want to start with either B or D. I would start with B just because it's a nice round number. So let's assume there were 10. And it's doubled every 3 years. So that would go 20 after 3 years, 40 after 6 years, 80 after 9 years. We know we need a bigger number.
Yeah. So then you'd do D.
Then you do D. 40 goes 40, 80, 160, 320. That's too many. We know the answer is C without doing any more work.
Gotcha.
And we never had to deal with this crazy function here. I think that was just put in there to confuse us.
To intimidate us.
To intimidate us, exactly. All the key information is it doubles every 3 years, and there were 160 turtles 9 years after it was discovered.
Gotcha.
In fact, that's a beautiful question as the quintessential back-solving question, I think. Especially because you knew whether you needed more or less when you tried one. How many times does this graph cross the x-axis?
Once. Or twice. Twice. Twice.
Twice. That is the graph of y equal x squared shifted down by 6 units.
Yeah. Sorry, that took a second.
It's okay. Now, how many times does this cross the x-axis?
Never.
Exactly. It has only imaginary solutions, in fact. Imaginary solutions do not cross the x-axis. Only real ones do.
Okay.
And you could solve that x equal plus or minus square root of 6. There's the 2 spots that it crosses.
So it'd be at 3 and negative 3?
No, negative square root of 6 and positive square root of 6. In other words, we're solving x squared equals 6. Take square root of both sides, you get plus or minus square root of 6.
Got it.
Okay.
So we can rule out that it crosses the y-axis in a positive point.
Yep.
So B and D are out.
Okay.
It doesn't cross the x-axis at 4. I'm saying it's C.
Okay.
No, never mind.
Let's think about it a little bit more. Don't be quite so hasty to guess.
Yeah,
I think that might be part of your issue. I think you need to not guess as quickly as you do.
Okay.
Just because you know enough math that you should, given enough time, you should be able to get all of these, every single one of them right. The only criterion is going to be speed. So the only reason for you to ever guess is speed.
Right.
certainly don't guess if there's still stuff we can do to figure it out. It's not going to be A because a slope of 0.3 is a flat slope. This is quite a vertical slope. And in fact, that would be a slope of 1, which kind of looks like that. The question is that a slope of 1.3 or is it a slope of 4?
If it was 4, it'd be more vertical, wouldn't it?
I would think so, but I don't know. The better technique is let's find the x-intercept. We're between 1.3x minus 3 or 4x minus 3. It's one of those two. Well, if we set the x-intercept is where they're equal to 0. In this case, x would be 4/3. That doesn't look right. In this case, x would be 2 and change. 3 divided by 1.3. That looks right.
Okay.
I'm certain that C is the right answer now. I'm not sure that I really could tell the difference between a slope of 1.3 and a slope of 4. I couldn't, in fact. I wasn't positive. First of all, these 3 points here look closer to a slope of 4 to me. But if you put that point with this point up here, maybe that's closer to a slope of 1.3. But finding that x-axis was definitely helpful because x equal 4/3 is way over here, which could be actually. And x equal 2 and change is right there, which could be. I'm not sure it's that definitive, to be honest.
That's kind of a bad question.
Yeah, it is kind of a bad question. I'm still pretty sure that the answer is C, but it's all really going to depend on how you draw your line of best fit. In other words, if you let the calculator do it by using a linear regression, I'm sure it'll come up with C. But definitely all right. Geometry.
So C is equal to 50. What is the value of A minus B? Oh. So A plus B is equal to 180.
How'd you get that?
And
How'd you get that?
because you can, I mean, A
Actually,
plus the
if B is that, then B is also that.
Yeah.
So now,
And then A is the other.
now there's an exterior angle formula that says that A is equal to the sum of B plus 50. And the reason that's the case is because A is supplementary to this, and the sum of these two angles is also supplementary to that. So this has to equal that. In other words, let me put an angle C in there. A is supplementary to C, and B plus C, or B plus 50, is also supplementary to C. Therefore, A is equal B plus 50. Now you can figure out what A minus B is. What's A minus B?
50.
Uh-huh.
That's a weird problem.
It is, and that's kind of a weird geometry fact, but it's usually presented like this. C is equal to A plus
Oh,
B.
okay.
The C is the
Yeah.
exterior angle, and it's equal to the sum of the two angles that it's not supplementary to, the other two. Okay, number 9, all by itself, that's not that table isn't part of it.
I'm sorry. Oh, there it is. Okay.
Ah,
Q,
this is the section of the SAT that is not multiple choice. You knew that, didn't you? You've taken an SAT.
Yeah.
Yeah, this is the, what do they call it, the grid part?
Yeah.
And the only trick on the grid part is knowing how to put the grid in. You got to be a little careful.
Yeah.
What is Q equal to here?
Q is going to be 1.4.
Okay, you could grid it in like that. It's also 7/5. You could grid it in like that. The one way you cannot grid it in is 1 2/5.
Because it'd go in as 12 bits.
Yes. Don't grid in a proper fraction. Only improper fractions or decimals or quotients.
Okay.
7/5 is fine. That's an improper fraction. Okay. Silly yo-yo.
Wait, what?
Huh?
Oh, okay. So, the total small yo-yos would be 18,000.
Right here?
No, down. Small total.
Okay. Which makes
That's
that,
18. 8.
so that's 800 and 500 is 1,300.
Mm-hmm.
So 1,300 is the answer. Okay. Yeah.
I hate prime numbers.
Well, let's pick some. Give me 2 prime numbers greater than 2.
3 and 5.
P is equal to 3 times 5, which is 15. How many positive factors does 15 have?
None.
It's got 2, 5 and 3.
Oh,
Plus,
sorry. Positive, not even. Oh my gosh, I'm sorry.
okay, including 1 and P. So it really has 3, 5, 1, and 15. And it's never going to have more than that. The reason is if you take 2 prime numbers and multiply them together, there can't be any other factors other than the prime numbers. That's kind of the whole point of prime number analysis. So there's always going to be 4.
Okay.
Okay? As long as 2 is not one of them. On the GMAT, oh, incidentally, did you see where they've changed the SAT? No essay anymore.
No.
Well, I don't think the change goes into
Really?
effect until 2016. Yeah, the maximum score is going back to 1,600 instead of 2,400. Essay is maybe voluntary. I'm not even sure it's going to be included anymore. But the biggest change is there's going to be a no calculator section on it.
Oh.
Which is really new. As far as I can remember, you've been able to use a calculator on SAT. So, but like I said, I don't think that will affect you. Close.
Yeah, probably not.
If it doesn't go into effect until 2016, you'll be completely done. But if it goes into effect 2015, you may face a different SAT next year if you take it in the fall. Well, the fall would still be 2014. So,
yeah,
you're probably okay. Well, and I'm not sure okay. You might be better off.
yeah.
Personally, I'd be better off without the essay and with no calculator. So.
Yeah.
Okay, and I suspect you would be too. The length and width of rectangle are integers. If the area is 85, what is one possible value for the perimeter of a rectangle? The length and width are integers, and the area equals length times width equals 85. What is one possible?
85 and 1.
There you go. I was just thinking to do that myself, too. Why fool around with trying to factor that?
So 172.
Mm-hmm. Very good. Not that, I mean, we could have factored it by 5, so it wouldn't have been too hard. It would have been a much better problem if they'd have said 83, I think. Maybe not. I don't know.
I still would have done 1 and 83.
Well, that's the only factors of 83. That's why it's a better problem.
Gotcha.
In other words, 85, we could have had 5 and whatever, 21. Not 21.
But would they take both answers?
Yeah, this only says what is one possible value for the perimeter.
Gotcha.
So there are multiple answers for sure.
Oh, I don't like that.
Well, I'm curious. This looks like a logarithmic problem to me, but I don't know. Maybe I'm missing something. So 7,680 is n, right?
Yes.
And we have to solve for t. So we have this equation.
Ew, it is logarithmic.
Yeah, but they're not going to give you a log problem on the SAT. Well, first of all, it might be easily solved. If we divide both sides by 120, do you have your calculator handy? Probably better if you have it out than me having it out, since...
It's 64.
So 64, yeah, equals 2 to the t over 6. Now, we could actually take the log base 2 of both sides. Instead of taking the natural log, which is going to present us with a problem that has to be solved using a calculator, let's take the log base 2 which we can do without a calculator. The log base 2 of the right side is t over 6. Log base 2 of the left side is 2 to what power is equal to 64? 2 to the 6th power. T is equal to 36, and we didn't have to use logs. I mean, we did use logs, but we didn't have to use a calculator table of logs because they gave us numbers that were all had a common exponential base. In other words, as long as I could make the log base 2, I could figure that out in my head. Is there a way to do that without using logs? Yes, there is. It would be a little bit lengthy, and that is no, there really isn't. Oh, and incidentally, yeah, we figured 36 years, right?
Yeah.
So the answer is 1936, not 36. Be careful about these questions. Sometimes you can go to a lot of work to figure out the answer, and if you don't read the question carefully, put down the wrong answer, especially on the non-multiple choice ones. You could almost do a little trial and error on this. Like 120 doubles every 6 years. So 120 to the x has to equal 7680. I guess that's the same problem. It's a log problem. All right.
Yeah.
Not sure there's a way to do it without bringing in logs at some level. I don't think there is, but that surprises me because I don't remember logs being part of the SAT. The SAT subject test for sure, but not, I didn't think part of the SAT regular test.
Okay, so x is going to be 1 second. X is going to be 85.
Good. I don't know. That's not one of the higher difficulties ones. It's just on the same page as the ones I was trying to capture.
Yeah.
You might be worth, let's see, questions 9 and 10 apply to this graph. This is probably better practice for your science section on the ACT, but that's okay.
Africa?
I think you just have to do the math on each one of these. Does Africa?
It doesn't look like it.
No, because 1/5 would be 1/5 of 200, which is 40, and they have more than 40. So they don't have less than 1/5.
The only possible is Europe.
Well, what about Asia? What's 1/5 of 150? Oh,
It's
yeah.
less than 40.
Yeah, you're right. It's 30. Okay, Europe is 1/5 of 50, which is 10. That's clearly less than 10.
Yeah.
So 1 is the answer, B. And let's see, this is going to be hard to even see the question, but Okay. From 60 to 70, the total number of smallpox cases in the 4 continents shown above decreased by what percentage? The total number of... Yeah, I guess. Yeah, I don't know how else to do it.
Okay.
But that's all it is. We don't need to actually do it. In other words, you add up the whites, you add up the grays, figure out the difference, take that difference, divide by the whites. Right?
Okay.
Always divide by the original whenever you're trying to find net change. It's never dividing by the new number. It's always the original number.
Whoa, what?
Best way to do these is to write out the equations and see what you see.
It'd be A, though.
Okay, I don't even know yet because I haven't written out the equation. You're probably right. You're probably doing it in your head ahead of me, but the average of A, B, and C is A plus B plus C divided by 3, and they're saying that's equal to P. So what is the average of A, B, C, and D? Well, A plus B plus C plus D divided by 4 is what they're looking for.
It's D. I lied. I'm sorry.
Okay, so you solved for A plus B plus C is equal to 3P, and you substituted 3P for that, right? So 3P plus D over 4.
Why couldn't it be D? Because A was my original thought.
A is correct.
Okay.
Here, let's go through it.
No, I understand what you did.
Okay. Yeah. In other words, you solve for A plus B plus C, and then you just substitute it into the second one. But the whole thing becomes very doable only after you write it out. In other words, this is a key step right here. If you try to do the whole thing in your head, although you did get it right, doing the whole thing in your head, I don't know how you did it, but it's an easy problem if you just write it out like that. It's not even difficult.
Oh, so you have to figure out how many seconds there are in a mile, and then divide that number by that, and then multiply by 10. Right?
Yeah, miles per hour. The trick, whenever you're converting something, is to make sure your conversion factor gets rid of what you want to get rid of. I want to get rid of hours, right? I want miles per second, basically. So there are there is 1 hour per 60 minutes. That gives me miles per minute. And there is 1 minute per 60 seconds. So that number will give me miles per second multiplied by 10, just like you said. Isn't that what you said?
Yeah.
Okay.
And it's going to be 4.
Okay. Let's see. It should be 1 and change. It's got to be 13. It's got to be C. I can do that without doing the math. Notice that 60 times 60 is 3,600. That divided by 3,600 is 1 and change. Multiplied by 10 has to be 10 and change. Has to be C. And this is very typical. They put answers with such huge ranges in them that having a calculator is not really a big advantage at all. It might look like it on this problem that the calculator was a huge advantage, but it wasn't at all. No, because they put such a range in there, wasn't even hardly useful. Oh, 13 I love. I love this problem. And this kind of problem is on a lot of tests, not just SAT and ACT, but also when you go to grad school and you take your GMAT or GRE, you'll find problems like this.
I'm not good with problems like this.
Okay, let me give you a hint. What's the sum of these numbers?
0.
Okay. What's the sum of those numbers?
0.
What's the sum of those numbers?
1.
34. If the sum of these numbers is 0, then the sum of these numbers has to be just the addition of 34.
Oh.
So how many we're not done yet. How many digits did we have from negative 33 to 33?
66. So 67.
Count 0.
Okay.
So the answer is 68. In other words, there were 67 digits from minus 33 to plus 33. That's the 68th digit. And that is a very typical problem. I can't tell you how often I've seen that. And it just requires a little bit of out-of-the-box thinking, I guess. Not really even, but this concept up here is the key thing. When you go from minus of a number to plus of the number, they all add to 0.
Gotcha.
That's an isosceles triangle with that equal to that.
It's just 13 times 13, isn't it?
That's equal to that. Two identical isosceles triangles. That's 13. And, oh no, the side length is 13. So it's 13, 13, 13, 13, and 10. The area of the quadrilateral how are we going to do it? Can you assume that that's a parallelogram?
Yes.
I don't think you can.
Why?
Well, I don't know. I can't prove it's a parallelogram. Even if you could, how are you going to get the area of it?
Well, how would it not be a parallelogram if the side
Well,
lines all match?
okay, you might be right, but the problem still, it doesn't facilitate the solution. Because if it was a parallelogram, you would need the vertical height. How are we going to get that vertical height? That's going to be impossible.
It's 13.
No, that's the lateral height. Remember, the area of a parallelogram is the base times the vertical height. The vertical height is this height right here.
Okay.
Okay? So, the better way to do this is figure out the area of the triangle, which actually is fairly easy to do. We know it's isosceles, so if I drop a vertical, this is a 5, what's the height of this triangle?
I don't.
Think perfect Pythagorean triangles. You got 3, 4, 5 is one. What's the next lowest one? 5, 12, 13.
Oh.
So that's 12.
Okay.
So that dimension is 12. Now I can figure out the area of that triangle, multiply it by 2. So it's 120 is the area of that thing. And I cannot think of any other way to get it than that. Because try dropping a vertical, even if that is a parallelogram, and it might indeed be, I don't know, I'm not good with trying to figure out shapes like that, with whether I can draw these things and not have these two things be parallel. But even if it was, to drop a perpendicular there, there's no way I'm going to be able to figure out what that height is. Impossible, I think. Okay. Let's see what happened to 15 here. Okay, 15 has got what I call the symbol problems. This is where they make up symbols that basically are mathematical functions, or it's supposed to represent what the function does. And most of these are very straightforward substitution problems. I've never seen one of these that's that hard. If you just look at it as a substitution problem. In other words, spade x spade is defined as square root of x minus 1. In other words, spade 1 spade equals that. So what is spade 37 spade equal?
$37 times that?
We're going to substitute 37 for x. Notice that that's how they define this function, is whatever's in between the two spades goes for x. So that would be the square root of 37 minus 1, which is 6.
Okay.
Spade 5 spade is what?
Square root of 25.
Not 25, 5.
5 minus 1, which is 2.
6 minus 2
4.
is 4. And they're almost always that easy. I've seen them one level more difficult than that. But just make sure that you're substituting, and that's all the problems really are. Now this little thing here for x greater than or equal to 1, notice what that does. It merely says that it defines the domain. In other words, obviously x can't be less than 1 or we'd be taking the square root of a negative number.
Yeah.
So that's all that means. And there'll be a lot of little things like that on these questions that you really don't have to pay any attention to. In other words, you could black that out and it wouldn't change anything. You'd still do the problem exactly the same. It's kind of like when they say 1 over x and x can't be equal to 0. You don't really need that information. You know that.
You don't really pay attention to it.
Yeah, exactly. Okay, this one's a good one. I'm glad we came across it because this one is memorization. When you have a rectangular brick, whether it's a cube or not, I'm such a horrible artist. Amazing I can do math at all. If you take its 3 dimensions, width times length times height, the distance between opposite diagonals, there's an equation for that. And it's much like what you would think it would be, only not quite. You might think that it would be the square root of each one cubed, the sum of the cubes, right? I mean, if you're following Pythagorean theorem and you use the kind of logic that the Pythagorean theorem uses only in 3 dimensions, we might be inclined, but it's the square root of the sum of the squares. That is the length of D. In other words, it's very much like the Pythagorean theorem, only it's still squares inside. Oddly enough, given that it's a cubic structure. I mean a 3-dimensional structure. So in this case, the answer is quite simple. Square root of 3 squared plus 3 squared plus 3 squared, that's the square root of 29 or 27, which is 3 square roots of 3.
Okay.
Now you could spend an awful lot of time breaking this down into different planes, trying to use the Pythagorean theorem on each plane to come up with this diagonal here. Notice there are multiple planes you'd have to work with. That would take about 5 minutes for me to do at least. So knowing this formula really saves you a lot of time on this question. And I'd almost guess that you're going to get a question exactly like this. The odds are strong that you'd get one that asks about that diagonal. So remember this formula. Saves a lot of time. All right, why don't we end it on 16, that page. So Sunday, I can look forward to chapter 9495.
Either that or he gave us more AP review problems. So.
Okay.
Would you like me to email those to you?
You don't need to. Just hold on to them. I think that there is something to be gained by me not knowing the answers.
Okay.
Especially since you don't have to have the answers for Monday morning. You know, if you were taking a test Monday morning, maybe that wouldn't be the best way to proceed. But given we'll be meeting repeatedly, yeah, no, I think it's useful for you to see me. If I don't know how to do it, for you to see me how I try to work it out.
Okay.
So I will see you Sunday at 4 or 4:30?
4:30.
4:30.
Yeah, 4:30. Okay.
Okay? Have a good weekend. I'll see you then.
You too.
Bye-bye.